Okay, let's move to the okay. So now these four learning outcome is important. Uh, Remember how we set the question up. TL1 will be in your final exam question 1. TL2 will question 2. TL3 will be in question 3. TL4 will be in question 4. For second half, I will highlight a few two quality quality tools. Right, but before that, remember to do your student evaluation. And okay, so for the next 10 minutes, I will introduce you a tool used to monitor the process, whether uh, it is in control or out of control. Okay. The rest I'll go very fast. Yeah, I'll go very fast. Um, when talk about quality, this chapter will be more on the quality, how you monitor the qualities. So quality, you have two perspectives from the customer's eyes, fitness and quality. Fitness is you look at the functional, for example, the one on the top, and the quality of design. So, and it's more on the characteristics, design characteristics, right? So the two car that you see on the screen there actually have a different quality and um, the different market segment they want to go into. Right? Okay. All right. So this will be a quality dimension of manufactured products. This will be the dimension. We have 9 dimension. Okay, 9 dimension. Uh, it can be in your question 4, or maybe question 3. It will ask you something, maybe 4 point or 5 point from here. Okay, all this you read. For second half, you look at the quality, how you monitor the quality, either in control or out of control. All these things are um, is important. So one is quality of conformance. What I mean by conformance is to make sure the products is produced according to design. For example, the tires, the tires. So if they do not conform, they do not meet the quality of conformance, the tires will wobble, and it's not safe. So hotel room that is not clean, then it's not conformance. The quality is not conformance. Okay. So this when we talk about quality just now, there are two perspectives. One is from on the left is from the producer perspective, and another one from the customer perspective. So these two must be balanced at the end of the process. So on the one producer perspective, the quality of conformance, they look at specification and cost. Customer perspective, they look at quality of design. They look at the characteristic and price. So there are these two different domain that you need to be careful when you handle projects. There are two big dimensions. One is on the left is the producer or your companies. And the other one is the consumer perspective where your product is going to sell to the end user. Production is on the left, marketing is on the right. When you talk about marketing, means you'll talk about consumer. Talk about production, you talk about producer perspective. The rest you read. The rest you read. Okay, this is important. There are some famous people or some researcher, they talk about something, some theories. So no choice is part of your learnings. You need to remember a few gurus, name and model. So these are the gurus or the expert, quality expert. There are a few names. So the rest you read, what are their contributions? Okay. So this one might come up in question 1 or question 2. Depends on the type of the question. Okay. All this you read, huh? Okay. The first 3 and the second 3. So total you have 6 guru to read. For today, your homework, go and read what is all these gurus, what is the contribution, and all this. Yeah, 6. This is a very famous quality management system using Deming philosophy. There are 14 points. Go and read. Okay, and read. So Deming have ways of improving the qualities. There are 14 ways. Go and read. So if you go into manufacturing world later on, Deming can help you to solve some problems there. Okay, read. Deming wheels also important when you come to manufacturing quality control. 4 action: plan, do, check, and act. Okay, plan, do, check, and act. These 4 phrases is important in quality control. And it can be changed in other names when you use a certain people philosophy. But it's just evolving with these 4 main action: plan, do, check, and act. Okay. Quality tools, you have, what are the quality tools that you have to control the quality? You can use process flowchart. This one you read, process flowchart. Fishbone diagram, or you call it cause and effect diagram. This one usually you involve in a very complex manufacturing process. You will have a fishbone or cause effect diagram. Checklist is usual. Checklist. This one you read. Pareto analysis and histogram that you have learned in your mathematics. So Pareto is more on the percentage. Histogram is more on the frequency or number. The only difference is the y-axis. If you change your y-axis into numbers or the frequencies, or frequency means how many times it happened. 4 times, 5 times, 6 times, numbers. If you change into percentage, means 10 times how many it happened. Like 10 times, 2 times happened. So 2%, 20%. So you plot 20%. Okay. So the rest you read. Pareto, number of defects, scatter diagram. This one, when you use the Excel tools, this is called scatter. And then use scatter in Excel nowadays, you can plot trend line or trade line. Okay. For second half, you'll focus on this one. Statistical process control chart. We look at this one. How is in control or out of control? Okay, I'll try to explain this one in 10 minutes so that you can understand what is. So, okay. Yes. You have this one, right? In other module. So this one, you take this one before or currently to taking? No, I didn't. Other? Operation. During diploma or what? You haven't take, right? You guys haven't take or already take? Okay. So you haven't take, right? Some of you haven't take, right? Okay, so three already take. You already take. Okay, take already? No. Next year, next time. Last semester, last year. Okay. Then I will go very fast since you already know this one already. So upper limit, lower limit, how it's in control. All right. Okay, so TQM, this one you learn in your quality control, this one already. The principle of TQM, I think this one also already covered, right? Okay, so Six Sigma, have you learned Six Sigma previously? Yeah. So Six Sigma, very famous one is Motorola. They are the founders or the first company using this one, Six Sigma. So the quadrant still come out from here. What I mean by Six Sigma? You divide into 6 quadrants. And you do analysis, green belt, black belt, and so on. House of quality. Have you learned house of quality in previous module? You learn about this one? No. Yeah, huh? I'm not sure. But have you seen house of quality? You learn house of quality also, right? Okay. House of quality? No? Yeah. Okay. So if you want to know more about the quality statistic control, go to this book. It's a very good book, good textbook. Go and get it. Okay, so this one you learned already, so I'll go very fast lah. Statistical process SPC, upper limit, lower limit. Important is you know how to interpret the data. Okay. Okay, this is a control chart. So from here, you know that there's one point out of control. And actually, from sample number 6, from sample number 6, actually the system already out of control. Why? Because the dot already start to go towards upper limits. Okay, and one point is out of control. So you when you look at this control chart, you should able to come up with the solution to fix the problem. So here might be the machine already start to wear and tear, start to out of control already. You need to adjust back, maybe because of the vibration. The way you cut the things already start to run away already. All right. Or maybe the operator start to fatigue. Operator start to fatigue already. Means it works for long hours and he want to fall asleep already. So when he do the work, the quality start to move towards upper limits already. Okay. These are the things. So this basically control chart and the Six Sigma graph or the normal curve actually is the same. Only you flip, you make this normal curve here, you flip it vertically. You have a P chart, C chart. Have you learned about P chart, C chart? No. You only learn one type. Have you seen this one? Or you only learn about very basic? Learn also, right? P and C. Okay. So one is proportional, one is a number of effect. So don't confuse between the two lah. Okay. C chart, C chart. But since you already take this one already, you have seen this formula, right? How to find the upper limit, how to find the lower limit, all this. Okay. Since you already take already, then this one just for your info lah. Okay, just for your info. These are the tutorial how to do it. Just read through, huh? Just read through. So here there are some analysis or diagnostics of the data. So for example, you look at this one. First, you look at the trend. This one is moving upwards. The chart. Usually, when this kind of question come out, we look at a few argument or few point. First, where is the direction going? Does it go up? Does it in control or out of control? You need to answer that. So this one is actually in control, but you need to do correction as the data is moving upwards already. And 2 points are out of control. Huh? And there are some analysis of control, not in control. This one you read through since you already done already. To hide the steps. If you are plotting mean chart, you need to follow this criteria here. It's one slide. This one also constructing double mean chart. These are all the tutorial question. Okay. So since you already take the quality management control already, the operation module already. So this one I will just go through. This one you read through as your reading material. Okay, so this is the summaries lah. So when you do diagnostics, you have to tell what is the trend of that one. So either go up or go down. This one. And then you break into 6 quadrant or 3 zone A, zone B, zone C with a different sigma region. We call it pattern test. Run a pattern test for your control chart. Yeah, since you already take earlier the module, so I don't go deep into the explanation anymore. This chart is this slide is important. Is help you to identify whether is in control, out of control. There's 5 criteria. All right. So you break into different region. Then if 8 consecutive points are on one side, out of control. If 8 consecutive points up or down, also out of control. 14 points alternating up and down, also out of control. 2 out of 3 consecutive points in zone A on one side of the center line, also out of control. 4 out of 5 consecutive points in zone A or zone B, one side of the center line, also consider out of control scenario. Okay, so this one is a guidelines. So this is an example of doing analysis. This one side, one off, and so on. So these are the process capability chart. This one is just for info. These are the tools that you can use to improve the to produce a new products development. So this one you read through lah. Rambus design, concurrent design, and so on. Lean manufacturing. Have you heard about lean manufacturing? No? Okay. The word lean, the word lean, okay. So this one should be included in the quality something on the module, quality something. So if you see the word lean, lean manufacturing, yeah. Okay. Lean Six Sigma. Okay. You learn about Six Sigma, right? Previously? Yes. Okay. Six Sigma is how we improve it. Right? Focus on how to implement improvement using statistics data. And lean manufacturing, the word lean itself is to reduce waste in the process. Is to reduce waste. So you read through. Um, have you heard about Pokayoki? Go, no go? Yeah. It's a uh, very common approach in manufacturing line or nowadays design. Pokayoki means you prevent mistakes or you prevent stupid mistakes. For example, your SIM card, will have one corner here so that you know which side to put inside there. Your ATM card, your debit card, also same. Yeah. For example, how you implement Pokayoki in the production or in your design. Like for example, in the manufacturing or in the engineering application, you use some of the equipment, you use different nut. And especially in the aerospace industry, a certain nut you can only torque at a certain Newton. You cannot over torque it. You cannot over screw it in aerospace industry, right? Because if you over stress or over torque it, you will stress the material and it will create crack in the aerospace industry. So how you prevent, let's say you have 1, 2, 3, 4, 5, all these screw, and one of the screw, maybe 4 screw from here, you torque at a certain value, and another 4, you torque another value. How you use Pokoyoki method? You can use color, you can use shape. There are two approaches. This one. Pokoyaki, there are 3 types. So if it's a contact design, you use color, shape, and size to prevent the mistakes, right? So you change shape, triangular or hexagon or different size, right? M4, M5 screw, for example. If it's a fixed value, so fixed value means you can alert the operator with a fixed number of movement. Like you push in 6 times. For example, some elevator. You press 3 times, you can cancel the thing. Do you understand? Do you know that? Some elevator, some lift. You press level 1, level 2, level 3, level 4, right? Let's say you press the wrong number. 4. You can press some lift. You press double time, 2 times. It will cancel the thing. Something like that, right? Or for example, this one, a fixed value. How you start your computer, restart your computer, Control Alternate Delete, right? You know that, right? How to force start your phone? Do you know how to force start your phone? You press all the button, right? It will reset your phone. Actually, you press all the button, you let go, it will restart the whole phone. Let's say your phone jam and nothing works, hang there. What you do? You press all the button. is part of the Pokayaki design. Means that a normal people won't press all the button unless a certain scenario you press the button. And then if you use printer, there's a certain press button to reset the thing. You know that, right? So these are the things. Your smartwatch also, the number you press, the way you press your smartphone or press the thing will do. Like for example, my smartphone, my smartwatch can pay wireless payment. I can pay any payment with my watch, right? So there's a certain function that I press, I can pay with my phone, watch, my smartwatch, right? Motion steps. This one, there's a certain procedure to follow to appropriately. So this one, you need to follow. For example, this one is an ATM machine. Like you draw money. You draw money, there's a certain steps you need to follow. Right? Okay. Da, da, da. Okay, so another common tools they use to show that you're actually practicing quality management is the ISO 9001. If you go into any company that show you the ISO 9001, it means they are practicing the quality control. Okay. What else? Okay. So this also important table. If this one come out, I will tell you. But just go read through at the moment. So there are three gurus here: Deming, Johan, Cosby, quality management. Yeah. Pareto, trend analysis. This one already done. Done. Six Sigma. Okay. Pokayoki. So these are the example of Pokayoki. Your car seat belt also. Pokayoki. If you there's a certain way of using it. Your USB cable. But nowadays, USB cable becomes smarter and smarter. If you use C port, doesn't matter which direction you port also can, right? Uh, um, then the plug also. Um, your heart also Pokoyoki natural. Your blood flow cannot flow backflow at a certain portion of your heart because of the valve you have, right? Nowadays all the smart cars have Pokoyoki system also, right? Mm, Quality cycle. This one will be true. Okay. For this chapter 8, what I need to highlight is in the Deming cycle for improvement, for action, act, check, do, and plan. Our plan, do, check, act. This for action. Rhombus design. This one you come into your FYP or final year design. What are the rhombus design? Okay. Okay. So what mean by these two design? Standard design on the left is a fixed location. Means if you off 1 mm to the left, you cannot fit. Like for example, the mouse, the hole for the IC chip, these two hole here, right? This hole and this hole, they must be fit precisely. But if you have a rhombus design, you have a space for you to play around. Means you can fit the thing, but just exactly at the position you want it. There's some room for you to play. As you read, factorial experiment design, one factor, two factor things. Okay, this one I assume you already done in the other module. Okay. With this, we conclude chapter 8. The material actually available in Canvas already.